So this is a review of plate tectonics. I'll try and cover all the different plate boundaries and some of the main key concepts that you need to know. This first one is showing your mid-ocean ridges. Here shows the diverging boundaries in the middle of the Atlantic Ocean, where South America and Africa are being pushed apart as this convection current is rising here in the center. And the Nazca Plate over here on the Pacific side of South America and South America are converging, and we have a plate going down into the mantle. If we look at this is another version of that, you can see this is a seafloor spreading. These plates are moving apart. We have subduction happening here, and it's all happening because of what's going on here in the asthenosphere. And this next slide shows these convection currents. So the heat from the interior of the Earth, the outer core, is rising in certain places. As it rises because it's less dense. Once it heats up, the molecules move further away from one another, and they become less dense. They rise to the surface, and once they rise, they spread out from that spot, and that's what drives this mid-ocean ridge, these two plates moving apart. And as they move apart, the heat, it begins to cool, and then the convection cell starts to dive down into the mantle, deeper into the mantle, which draws these plates further underground, down in the mantle. And you see the spreading here, and these plates coming together because these convection currents are driving all of this. If we look at what's happening here, because this is rising, it pushes up the lithosphere in that spot, and it causes what we call a ridge, a mid-ocean ridge, and where it's breaking, it's called a rift or a rift zone. This is seen both in the middle of the ocean, but it's also seen where two continents are splitting, and two parts of the land are being split here and creating a new ocean. Right here, this is the Arabian Peninsula and Africa, and you can see that that is being divided in that place. And if we sort of look to see what's happening, the convection current's driving this, it's separating the continental crust, and this area is made out of basalt, which is more dense than the continent. It's lower, it ends up sinking as it's separating. It's quite a bit thinner there, and that allows water to eventually fill that space. So you first get this upwarping where the heat's rising up, pushing this land up, and pushing these plates apart, and eventually you get an ocean forming in between those two places, and that's what we have happening right here in the Arabian Peninsula in Africa. The Red Sea currently was because of that, and this whole area, the Great Rift Valley or East African Rift on the reference table, is caused by that. If we look to see what's happening when two plates are coming together, we get this area where a plate is subducting down underneath another plate. Again, you can see this basaltic ocean crust is much denser. It's also thinner than this continental crust. The density is really what causes the ocean to drive down underneath. Density of the basalt is 3.0. Density of granite is 2.7. So this is going to always go down underneath the continental crust. And as you see in this diagram, as this plate goes down, it heats up this lithospheric crust and melts and rises, and you get these volcanoes formed as these two plates come together. And as that drives down, you also get these deep sea trenches where the two plates are converging. Some other examples of this in the United States, Mount Shasta is a good example. Many of the Rocky Mountains were formed from this type of convergent boundary. We can also see this happening in South America, where the Andes, these mountains right along the coast, the west coast of South America, were created because these two plates are coming together. We also get deeper earthquakes happening in these areas as you go inland, because the earthquakes are happening where these two plates are moving against one another, And as you move inland away from that trench, you get deeper earthquakes because that is driving down the into the mantle. Um, the last thing that I wanted to show you was in terms of convergent boundaries is what's happening with India when you have two continents coming together. You get India, let's say, and Asia. When these two collided, the neither of these are less dense, so they just crash together and they build up. That continent rises, and so you get the Andes Mountains. And this is sort of what happened with India. 70 million years ago, it was here, and as it's moved to its present location, the Himalaya Mountains here are being created from that. The last thing in terms of what's happening with plate boundaries would be if we look at transform boundaries. And you can see this shows all three different kinds of boundaries. You have a convergent boundary here, a divergent boundary right here, and as these two plates are moving past one another, this plate is moving to the east, this plate's moving to the west, and you get a transform boundary right there. So they're not coming together, they're not going apart, they're just sliding past one another. Another important idea is this idea of a hotspot. It's a location inside the earth where lava is flowing up. It's very similar to what we saw with the lava lamp. And as it rises, it breaks through this oceanic crust, and lava hardens on the ocean floor and it builds up year after year after year slowly, and eventually rises up, is taller than the ocean than sea level, and so you create an island. And as the plate moves, the island changes. Um, you get new islands created. So as the Hawaiian Islands, as this plate moves over this Hawaiian hotspot, um, these new islands are created. The plate moves some more, another island, plate moves some more, another island, until we have Hawaii here today. All of this is in your reference table. If we look at the reference table here, you'll see that this boundary or this example shows what's happening when you look at the divergent boundaries here, convergent boundaries here, transform boundaries here. The bottom of this page, page 5 in your reference table, there's a key. These hotspots are important, and these arrows show you which direction these plates are moving. I hope this was helpful in reviewing some of the key concepts in plate tectonics.